Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be talking about some more examples of Vogel's approximation method, that is VAM method. In the last lecture, we have discussed the balanced transportation problems. So in today's class, we'll be discussing about the unbalanced transportation problems. So in this method, as we know that we have to calculate the penalties for each row and column. So the steps we have already discussed. So how do we calculate the penalty? It is the difference between the smallest and the second smallest cost cell in the particular row or a column. So we have to do it for all the rows and the columns, and then we have to identify the row or column which has the largest penalty, the maximum penalty. And the rest of the steps are same as we do in the other methods. So we can see here, this is we are having three sources XYZ and four destinations ABCD, and when we calculate their supply, the total of the supply that we have here is um, this is 500, 700. This is coming out to be 700, and when we'll sum up this is coming out to be 790. So this is an unbalanced transportation problem. So how we can make it balance? We can balance it by adding a dummy row. So how can we add a dummy row, and why we are adding just a row and not the column? Because we know that the supply was 700, the supply was less than the demand, which is 790. So we can, how can we make them equal? If 700 we add 90, then it becomes equal to 790. So the supply would then be equal to demand. So 90 is there, so we add a dummy row with the 90 supply. So what would be the cost in that particular row? The cost for each destination would be 0, because there is no such source exist, so there would be 0 cost associated with it. So now you can see here, we have 200, 350, 150, and the last one is 90 for the supply, and there is no change in the demand. In some cases, if the supply is greater than the demand, then we'll be adding a dummy column instead of the row in this case. So you can note that for the unbalanced transportation problems, whenever supply is less than demand, you have to add a dummy row, and if supply is greater than the demand, then you have to add a dummy column. The dummy column would also have the same cost 0, but the total demand would be that number which can make both of them equal, the supply and the demand equal. So let's move ahead and let's see how we can find out the solution using the VAM method in this case. So let us calculate the penalty here. So 13 is the lowest, 16 second lowest, so that's coming out to be 3. Here it is 1, 14 minus 13, 10 minus 9, 0 minus 0, and this is 14 minus 9, so that's 5, 13 minus 0, then 19 minus 0, and lastly 10 minus 0. So here we could see this is the largest penalty that we have. So I'll be taking, considering the lowest one is 0. So out of the demand and supply, 90 is the lowest, supply is the lowest. So I'll be allotting 90 units here. So this becomes 0 and this is 210. So automatically what we observe that we have to delete this particular row, because there cannot be any other allocation from the dummy source to any of the destinations. So this is gone. Now again we'll be calculating the penalties. So the penalties would be, now the rows penalty would remain the same. There is no difference, you can check, but the difference would be in these penalties. So 14 minus 9 is this should be 9, not 14 minus 9. Okay, sorry. So this would be 5, and this is 13 minus 13, 0. So 22 minus 19 is 3. Lastly, 15 minus 10 is 10. So the largest that we have is 10. So in this particular column, 10 is the lowest, 150 supply, 250 demand. So the minimum from the 250 and 150 is 150. So I'll be allotting 150 units. This becomes 0 and this becomes 100. So again, now we'll be deleting this particular row, because from this source Z, no other destination we can supply anything, because the supply has become 0. Now again calculating the same penalties. So here it would be 16 minus 14, 2, 13 minus 13, 0, 22, this is 3. There is no change in this, so as we cannot do anything here, so that's a dash you can just write down. Now the maximum that we have is 3. There is a tie here also, we are having 3 in the first row, and in the C column also we are having 3. So you can consider any one. So I'll be considering the row. Let me take row this time. So the lowest is 13. So in this particular cell, 140 and 140 is the demand, 200 is the supply. So 140 is the minimum. So I'll be allotting 140 units here. This becomes 0 and this is 60. So now I cannot allot anything here. So we can see that I'll be deleting this particular column, and this is gone. Now to find the penalties of the rest, this would be 16 minus 14, that is 2. This is 3 again, and this is 2. So here it would be 14 minus 15, 1. So the maximum that we'll be taking at this time would again be the third one. So in the third one, we'll be considering 19. So 19 is the minimum cost cell. Now in this minimum cost cell, the number of allocations would be 210, because that's the minimum, and 350. So I'll be getting this as 140. So again this column is gone. So just now we would notice that we are having the rest. 16 minus 14 is 2. This is 2. This is 1 and 1. So you can take any of the columns. So now I'll be taking this particular column. I'll take this column. So here I'll get this as the minimum cost cell, 140 and 100. So obviously 100 would be the units allotted, and this becomes 40. So again this is gone. This particular column is gone. Now we have only this column, and in this column we'll be selecting the minimum cost cell, that is 15. So 100 and 40, I'll be allotting 40. So this becomes 0. This is 60. And again 17, in this 60 is the demand, 60 is the supply. So this is what we got. So now here we could see easily that the m plus n minus 1, we'll be considering the dummy row as well. So there are 8 total rows and columns. So minus 1, that's 7 allocations. 1, 2, 3, 4, 5, 6, 7. Yes, we have 7 positive allocations. That means we are achieved the minimum positive allocations. So it's a degenerate solution. Now the minimum cost that would be having, it would be, you will be just multiplying the cost per unit with the number of units, and you can calculate its answer, and it's very easy to find out. So this is how we can find. Last would be 0 into 90, so that's just 0. So you can calculate this, and this is how we can achieve the minimum cost using the VAM method for the unbalanced transportation problems. So let us consider another example. This is also the unbalanced one where the supply is 34 and the demand is 44. So supply is less than demand. That means we have to add a dummy row with the supply. The supply, how we have calculated 10 would be the demand minus supply, that's coming out to be 10. So this is how we can calculate the value that what we'll be writing here. So now calculating the penalties quickly, we could find it out. This is 30 minus or 19 minus 10, 10, 12, 0. So 19 minus 0, 8, 40. This is 10. So the maximum that we have is 40. So the lowest is 0. So this is 10. And this is gone. This is 7. So we could see here that this is gone. The row has gone. So we cannot allot anything here. Now moving ahead, calculating again. So now this will change. So 40 minus 19 would be 21. This is 30 minus 8, that's 22. This is 10. This is again 10. There is no difference in this. So the maximum penalty that we have is of 22. In this, the lowest one is 8. So out of the demand and supply, demand is less. So allotting 8 units, this becomes 10. So now as we could see, again this is gone. So this destination B has taken all the units, whatever was the demand available to them. So this is gone. So now calculating the penalties again, this would be 21 and this is 10 again, 10 again. There is no difference in this. There could be difference here. So it would be now 9. This is 60 minus 40. And here 40 minus 20. So the maximum that we have is 21 and the lowest is 19. So out of the demand and supply, demand is 5, so it becomes 0 and this is 2. So again the destination has met all his demands, so we cannot calculate anything here. So this is also gone. Now we are left with only 2 columns and the 2 rows. So again calculating their penalties. So this would be 20 minus 10, 50 minus 40, 50 minus 10 is 40, 60 is 20 and this is 50. So now this is the largest of all the penalties. 20 is the minimum cost cell. So out of the demand and supply, supply is less. So this is it. Then again we are done with the Z source. So they cannot give anything to any of the destinations that is left. So now calculating again. So we will be having 10. This is 50. This is 40 and 20. So 50 is the maximum. So we'll be considering 10 the lowest cost cell in this, so that out of 4 and 2, 2 is minimum. So allotting 2 units here and again this is gone. So source X is also gone. So we cannot allot anything here. And after that we are just left with the 40 and 60 in that particular second row. So 40 is the minimum, so I'll be allotting 7 and 9. 7 is the minimum, so this is gone. And then 60 is left, so 2. As you can see, the demand and supply are equal. So as m plus n minus 1 is again 7, so we could calculate that we are getting 7 positive allocation. So we have got the degenerate basic feasible solution, and the minimum cost again can be calculated using the same 19 into 5. 2 into 10, 7 into 40, 60 into 2, 8 into 8, 20 into 10, and lastly 10 into 0, that is 0. So we could quickly calculate the value. So this is what we have achieved in this minimum cost. So this is how we can calculate the initial basic feasible solution using the BAM method for both transportation balanced and the unbalanced transportation problems.